Hello guys, welcome back to Engineer 1. Today I'm going to be covering a mechanics of material torsion problem for you guys. In this case, we have a circular pipe as shown in the diagram. The diameter of the pipe is 8 inches and it is subjected to 2 torques as shown. And we're asked to solve for the maximum shear stress experienced in the pipe in PSI. So if you think back to your mechanics of materials class, you'll realize that since we have torques applied on this pipe, those torques are going to generate shear stress in the pipe. So the first thing that we need to do is we need to go to our FE reference manual and pull up a couple of formulas for this problem. In this case, it's going to be these formulas right here. The first one is the torsion stress formula on FE manual page 134, and then right under it I have the formula for the polar moment of inertia for a circular shape, and you can find that one on page 99 of the manual. Okay, so I'm just going to rewrite our formula for the torsion stress over here for us. There it is. And this torque is going to be the resultant torque that is on the pipe. So in this case, the resultant torque would be just the difference of the torques that we were given. Because as you can see, those two torques are applied in opposite directions. So the first one is 50 pound-feet. The next one is 30 pound-feet. So we're just going to take the difference of those two, and we're going to get 20 pound-feet. However, the solution we're looking for at the end is in PSI. So let's convert that 20 pound-feet into pound-inches. So what we do is 20 pound-feet times 12 inches over 1 foot. And we're going to get 240 pound-inches. So now we have our resultant torque that we needed for the formula. The diameter of the pipe is 8 inches, so the radius for the pipe is 4 inches. Okay, so now we have these two. The next thing we need to do is we need to get the polar moment of inertia for the pipe. So in this case, the formula, as you can see here, is J equals pi. Down here it says A to the fourth. A stands for the radius. So the radius to the fourth all over 2. So let's just go ahead and plug in our numbers. Our radius is 4 inches to the fourth over 2, and we get that the polar moment of inertia in this case is 402 inches to the fourth. So now let's go ahead and plug into our maximum shear stress formula. So 240 pound-inches was our resultant torque, multiplied by our radius of 4 inches all over our polar moment of inertia, which in this case was 402 inches to the fourth. And once you solve that, the answer is 2.39 psi. So if you look at our multiple choice, the answer is C. So that was a pretty straightforward mechanics of materials problem. There was a few things going on and a couple of formulas we used, but if you just follow these steps, you should be able to tackle a problem like this on the FE exam. If you would like to see more problems like these in the future, make sure to subscribe, leave a comment, and leave a like. We also just did a couple of videos on calculator tips for the TI-36X Pro, so make sure to check those out and stay tuned for more content in the future. Thank you for your time, and I'll see you in the next video.